intercepts, and if you do the intercepts of it, you'd have an intercept at -4, and then you'd have an intercept at 4/3. And you can do that, but sometimes it'll create kind of messy graphs. On a standard form graph, it's nice to say, well, if I have an intercept of 4/3, I would maybe count by thirds, right? And it would make my life a little bit easier to graph it if I counted by thirds. But that might mess up this graph then. If I counted by thirds, then trying to count my rise over run could get really messy, trying to go up 1/1. So you might decide that it's easier to just convert this into slope intercept and say, I'm going to add 3 and add 3. So there's times when converting the two equations or inequalities to the same form makes the most sense. And then there's times when doing them both as standard form intercepts makes the most sense. But you have to kind of look at what you have in front of you first and make that determination. I have 2 graphs here, one with a y-intercept of 5 and one with a y-intercept of -4. So I have kind of a lot of space that I need to work with right now. One has a positive slope and one has a negative slope. So if you imagine this one up here working its way downward, the one down here working its way upward, they're going to kind of meet over here in this space. So if you can picture what they look like before you start to make your graph, you can imagine what your graph is going to maybe look like, and you know what kind of space to work, all right? When you graph a system of inequalities, it's not about the point that they cross at, though. It's about the shading. The solution is not this point. The solution is the overlapped shading. It's the space where the shading overlaps with each other. That's the solution. And it's an infinite number of solutions. It's not a single point that they cross at. It's an infinite number of solutions where they cross over and that overlap. So don't hyper-focus and be like, oh man, they cross, but they cross in a weird place. Who cares? It's all the place where they overlap that is a big deal. So start making that graph right now. I'll set some rulers out if you prefer to use rulers when you graph.
Yeah. I really should have that.
I agree. I can see the line.
Oh,
Thanks, man.
Five, 4, 3, 2, 1. When I start a graph, I sometimes leave the arrows off the end until I know just how big I need everything to be. I kind of imagined that this graph here would need this much space. I didn't need this much over here, but I'm giving myself some room for it just in case. Don't forget when you're graphing, you have to make those decisions about should the line be solid or dashed. Man, I know I'm going to regret using marker here. Always do. And these are both solid lines. And then remember when you're doing your shading for a line like this, if y is isolated and y is less, that means you shade below. So the shading for this one would be a shade below.
Wait. No, it's the other. I think it's the other.
Oh, see, I knew it! This one is the shade below. Always the way. Thank you, Claire.
Well, Claire, you draw the line and then shade it, and then you draw the other line.
And then this one is a shade above. There. And then in here, at least I didn't get very far. In here are all of the solutions. Everything in there is a solution. And because these are solid lines, everything on the lines are solutions as well. If one of those lines was dashed, they wouldn't even be on the lines, wouldn't even be solutions. That's important to remember, that the lines themselves, if they're dashed, are not solutions. I was not going to do a bunch of these. So are there questions? I do not want to leave you in a lurch, not understanding. Yes,
So this is kind of like 6-1, but now we're adding the shading and stuff.
you got it. Just for the sake of argument, MCAs would be really good about saying something like, in which quadrant are the solutions?
Second, first.
So first and fourth.
Right, here's 2, here's 3, and here's 4. So maybe number your quadrants real quick. Fun game of the MCAs is to ask about that.
Second quadrant.
Second quadrant and then first quadrant.
Doggone it! Why is being me so painful today? Yes. Was that what you were going to tell me? Okay, thank you. All right. All right, the other thing you're going to have to do is look at a graph and name or give the system of equations from it. On the worksheet, it's a little bit harder than what you see here, but I'm going to show you one right here. So if you were to look at this one and you had to write the system of equations for this, you'd look at like the blue line, right? And you'd say, all right, it has a y-intercept of 1. So it's a -1 y-intercept. I always write an equation or inequality in this format right here. That's always my go-to. You can write a standard form, but it's a whole hot mess. This is always the best way to go. You can also write this one. You want to write this one when this y-intercept is not easy to spot. So I'm going to say that again because that's why the worksheet is more challenging. So listen to me carefully here. When the y-intercept is not on an integer or a whole number, that's when you want to use this. Okay? That was when you want to go there. All right, so this is -1. And then your slope is 1x. You have a solid line, so you'd put like that. The shading on this blue line appears to be above, so you do like that. Try, if you could now, to write the inequality for that red dashed line. Write the inequality for that red dashed line right there. What's the inequality for that line? Drew, do you have it?
5 equals -1x plus 5.
Not, I got the 5. I'm down with, what's the slope instead? -1/2? Down 1/2? And this is definitely not equals. Does it shade above or shade below? That's the symbol for below. Does that make sense, you guys?
Yep.
Okay. And we use point slope, remember, when we cannot see that y-intercept. All right. The word problems. Oh, they're not too bad. You guys always get nervous about them. It says, suppose you have a job mowing lawns that pays $12 per hour. You also have a job at a clothing store that pays $10 an hour. You need to earn at least $350 per week. You can work no more than 35 hours per week, and you must work a minimum of 10 hours per week. What is a graph showing how many hours per week you can work at each job? Yes, ma'am.
Wouldn't you think you would just work 12 hours an hour instead of 10? Like, why?
I know. We were doing a problem like this in the standard form one with my other class. And they were like, why would you even mess with the $10 an hour job at all? And I don't know, like, what the constraints are. Like, you know what I mean? Maybe you can't. Maybe it's not an option.
I mean, but mowing lawns is more restrictive. You can't, like,
Right. Maybe you can't. You can only mow them so many times, you know, before the people are like, okay, and you've mowed my lawn 8 times this week. We're done.
I think it's short.
Yeah. Now you're just going to burn the lawn. Stop. I'm not paying you again. All right. So we have a lot of restrictions here and a lot of guidelines that we have to set. Let's start with this first part here where it says that suppose you have this job for $12 an hour and you also have this job for $10 an hour and you need to earn at least $350 per week. It does say how many hours per week can you work at each job. That's our 2 variables. So we're going to start with a few things we know, like hours, mowing, and hours. What the heck was the other job? At the clothing store. And mowing they mentioned first too, right?
Yep.
Okay, so we'll call that one X. And we'll call this one Y. Write that first equation based on those statements that we have. What would that equation look like? Well, inequality. We would have 12x plus 10y and 350, right? Like a standard form. But then it says you need to earn at least 350. So that means that 350 is the least you can earn. You want to earn more, but 350 is the smallest amount. Then it says that you must earn, it says you need to earn at least 350 a week, but you can work no more than 35 hours per week. When you talk about the hours, that's both things combined. Yep.
So wouldn't it be x plus y is less than or greater than 35?
X plus y, and let's do that 35 again. Because you said less than or greater than, but I don't think that's what you meant.
Oh, like the 35 is like greater than or equal to.
There we go. So this can't be more than 35. Write that one down. And then we also have this, you must work a minimum of 10 hours at the clothing store. That's probably just to keep the job. So the clothing store is Y and 10. And to be at the clothing store, this has to be at least 10. How many lines are going to be on this graph? 3. One's going to be a horizontal line, and these two will have intercepts. This one is going to be really easy because it's going to have an x-intercept of 35 and a y-intercept of 35, right? Y-intercept, x-intercept. This one right here will have a, if you took and go 10y equals 350 and divide both sides by 10, you'd get y equals 35. Someone take 350 divided by 12 for me real quick.
I got 29.16666.
Okay. Did you say 29.16?
Yeah.
Okay, so that's in 1/6, 29 and 1/6, so
150, 1/3, or 2/3.
because it's got that 1 in front of it. Okay, and it's that's okay that it's a partial amount right now because we're talking about hours. I don't know that you have to work full hours. We can plot a point somewhere in the middle. All right, let's start making our graph. We got all of our x and y intercepts that went really fast. We need to put mowing on the x-axis and clothing on the y-axis. And our highest intercept is 35, so we can probably count by 5s, right? We don't need to make this a huge graph. One, 2, 3, 4, 5, 6, 7. Let me go back. Oh man. Remember that when you make a graph, 0, 0 always has to be the corner of it, okay? And I'm going to count by 5s, but I'm going to write the 10s down so it looks neater to me. So this will be the mowing hours, and this will be the clothing store hours. And then start plotting your x and y intercepts on there. Notice how I don't have any negatives on this graph. Why is that? There are no negative hours, so you only have quadrant 1 in our graph. Check your intervals too. I did this skipping thing right here, but when I skipped, I did skip 110, skip 120. If you're skipping, make sure that the spaces are in between the first numbers and after. You got to keep those intervals always the same amount. All right, so I need one for 29. And 35. Now, when you graph a standard form, you have to pick the point 0, 0, right? So if I put 0 over here, is 0 greater than 350? No. That means 0 is not a solution for this one, so I have to shade above. So when I graph this equation right here, this one, that one's a shade above graph. Okay, and then I graph 35 again with a 35. And this one is 0 is less than 35. So this one's a shade below graph. So there's some overlap in the middle here. And then I have to graph y is greater than 10. Greater than or equal to 10. And there's going to be some more overlap up in here, which leaves me with anything that sits in here as my solution set. And if I was asked, what are 3 possible solutions to this, I could go in and say, I could pick numbers that mathematically fit all 3 of these. But that would be kind of clunky and take me a while to figure out. I could also go in here and be like, all right, 15, 18. Looks like it would sit right in here. And 2012 looks like it would sit right in here. Those are possible solutions of amount of hours I could work at each given job if it asks me for possible solutions. The word problems get a little bit clunky. When you do your homework tomorrow, there'll be 2 of them, okay? Graph these 2. Graph those 2 right now, and you can go about graphing this one as standard or as slope intercept, whatever makes you feel happy inside.